Next topic, quotient or factor group. Let H be a normal subgroup of a group G. Then the set G by H consists of all possible cosets of the subgroup H in a group G with the binary operation AH multiplied by BH is equal to AB multiplied by H. It means that the H is a subgroup, a normal H is a normal subgroup of the group G, and A is an element of the group G. Then the set AH is the left coset determined by an element A. The left coset of a subgroup H in a group G determined by an element A belong to the group G, and BH for an element B belong to the group G. The set BH is the left coset of the subgroup H in a group G determined by an element B. These two sets, and when we operate the element A and B with the binary operation defined in a group G, the resultant element is denoted by C. This is an element of the group G according to the definition of the group, and the element C of the group G determine the left cosets of the subgroup H in a group G, and this is also denoted by A multiplied by BH, and according to this condition that these are the two sets, these are the two subsets of the group G. These two left cosets are the subgroup of a group G, and the product of these two left cosets AH and BH, the result obtained from the product of these two sets is equal to the set obtained from the product of AB multiplied by H. This is the left coset determined by an element C, where C is equal to AB. This set which satisfy this binary operation is called quotient group or factor group. Also, by our previous theorem that if H is a normal subgroup of a group G, then the left coset determined by an element A belong to the group G is equal to the right coset determined by the same element of the subgroup H in a group G. That is, AH is equal to HA and BH is equal to HB. That is, the left coset determined by an element B belong to the group G is equal to the right coset determined by the same element H. The same element B belong to the group G. The right coset of the subgroup H in a group G. And according to the above condition that the set G by H is a set. This is a set. Therefore, according to the definition of set, we collect distinct element of the and the element of G by H is all possible cosets. Therefore, the coset determined by an element A, AH is equal to HA, and the coset determined by an element B, BH is equal to HB, and so on. Therefore, we collect the left coset, that is, we collect one of the set from these two sets according to the definition that this is a set, and in a set we collect distinct elements. Therefore, AH and BH and so on, these are the element of the set G by H. Therefore, in this set we collect all left or all right cosets of the subgroup H in a group G. Therefore, because all the left coset AH is equal to HA is equal to the right coset. The left coset determined by element B is equal to the right coset determined by the element B, and so on. Therefore, in this set we collect all the possible left cosets or all the possible right coset determined by the subgroup left or right cosets of the subgroup H in a group G determined by the elements of the group G.